Hey, what is going on, people? Today I'm gonna be solving the most asked question at Google right now, at least according to LeetCode, and that is the problem 843 from LeetCode. It's called Guess the Word. This is an interactive problem, and this is because they're gonna give you an interface with a function, and you're gonna be able to be calling this function, and it's gonna be returning a value. You're gonna be using that value in order to solve the problem. This problem is it's pretty hard, I gotta admit it. If you actually get it on your first interview, you probably are screwed up. Sorry for you. Next time you're gonna be doing better. Uh, Probably the percentage of people that actually solve it the first time straight up, it has to be extremely low. But now you're gonna be able to have a better chance to actually solving this if you get it on an upcoming interview. So according to the description, LeetCode, they're gonna give you up to 100, a list of up to 100 words. Each word is gonna be having 6 characters, and you will be able to call the interface up to 6 times. The way that you call the interface is by calling master.guess. So the interface, the function, and you're gonna be able to send a word here. So this word has to match a secret word, and that is the whole purpose of this problem. Secret has to match to word. It has to match to this word. And the first thing that must come to your mind is that each time that you try a word, you gotta be able to eliminate some words. And that should be the correct behavior to solve this problem. So the first thing that I'm gonna do is I'm gonna write some words on the whiteboard. Okay, as we can see over here, I wrote 5 words. The description says that they're gonna give you up to 100 words. However, for this example, we're gonna go through 5 words. It's gonna be the same idea, and then we're gonna implement the solution that we're gonna code on LeetCode. So over here, I want to write steps that we're gonna be following. So steps. And over here, for each word, we're gonna be trying to find how many words it has 0 matches with. And the reasoning because of this is because if 2 words have 0 matches, there's gonna be a probability of about 80% of that to happen. And that is because out of 26 characters, lowercase characters in the alphabet, 25 to match to the 6, that is going to be the amount of letters that we're going to have on each word is going to be about 80%. So the probability of 2 words to match, it's about to match 0 characters is about 80%. And if you want to learn more of the reason because of this, you can check out the birthday paradox, which pretty much explains why this happens. And so, as I mentioned, we want this 0 matches over here. 0 match. So we're going to be comparing each word to the other word. So we're going to have a candidate word and then all the other words. So the candidate, we're going to put it as a red. So in this case, our candidate is going to be LOP-IOP. It's randomly chosen. And then the word that we're going to be comparing to is going to be the second one. So CDC QWE. So the number of letters that they match corresponding to value and index is going to be 0 in this case. As you can see, they don't match any. And it's going to be 0 for all of them. So in this case, we're going to be putting a 4 over here, since it doesn't match any characters on this, any on this, any on this, and any on this. It's going to be 4. I don't want to go through it that much because it's pretty obvious that it doesn't match any. So on the next word, we're going to be choosing CDCQWE, which is the second word. And then we're going to be comparing it. We're going to be comparing this word to all the other words. So let's grab the first word. We know that it has 0 matches. As a matter of fact, all the words are gonna have at least one zero match because the first word had zero matches with all of them. So let's go to the third, compare the second with the third word. So CVA, Q, ASD, CVA, ASD. So if we go and compare each one by one, we see that these two match, these don't match, these don't match, these don't match, not match, not match. Since the first letter match in volume and index, we cannot increment the zero match on this one in respect with this one. So we go to the next word. Compare ABC, QWE. Do they match? No, 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 but they do match. So we cannot increment on that one either. So let's go to the next one. A, D, F, T, Y, U. Do they match? No. Do they match? Yes. So we cannot increment it. So the value that this one will have on zero matches will be 1, since it's only had zero matches with the first word. And if we go to the third one, we know that this one has zero matches with this one doesn't. Now, if we see this one doesn't, and if we see this one does. So the number of zero matches on this one is 2. If we go to the next one, this one is 1, and this one is 2. That is pretty much the idea, and we can write it on our steps so we can follow it later on. So first, find number of zero matches each word has in respect with the others. Now for step number 2, we're gonna be selecting the word with the fewest number of zero matches. So that word in this scenario will be this one. It has a tie with this word. This word has the same number of zero matches, but since this one comes first, I'm just gonna select that one. Another thing to mention is that we haven't selected the secret word. So I'm gonna be selecting this one, the next word as the secret. So the secret is gonna be CVA, ASD in our example. And let's grab the second step. So it's gonna be select word with smallest zero match. Okay, now that we have the selected word, it's gonna be CDCQW. Right on the third step is sending the word to master.guess, which is a function from the interface, and we have to store the value returned from the function. So send selected word to master, let's say just to master, and store value. Okay, so on this scenario, we're gonna have master.guess, and we're gonna be sending this word. And this word is gonna be compared to this word. So this function is gonna return us, it's gonna go like, does it match over here? Yes, so it has one match. So it has one match. Does it match over here? No. Does it match over here? No. Match? No. No. And no. So this one is gonna returns a 1. A 1 because only the C is the only one that it match. So now what we want to do is to eliminate all the other words that don't have exactly the same matches as this word. So we're gonna go through the list again, the list of words, and be comparing each word to the selected word and compare that it has exactly the same number of matches as the number returned by the function. So we go through list. For example, let me grab another color. We go does LOP IOP. Let's compare it. Does it have only one match? No, 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 and no. So this one gets eliminated. Pook. Next one, it gets skipped. CVA, ASD. So this one has one match, so that's good. No, 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 no. So this is good to go. Then we go to the next one. It's A, B, C, Q, W, E. So let's see a number of matches. 0, 0, 1, 2, 3, 4. So this one gets eliminated because it doesn't have the same number of matches as the return value. So this one gets eliminated. And finally, A, D, F, T, Y, U. No, yes, 1, 1, 1, 1, 1. So it only has one match, and this one has 0 matches, and this one has 4 matches. So we're only left with these 2 options. So now the next step is that our list is gonna be reduced a whole lot more. Oh, and also I want to mention that this word obviously gets eliminated because, as we saw, it's not the correct secret word. So all these is gonna get eliminated again. And now we're only gonna be left with the words that had the same number of matches. So CVA, ASD, and the other one is ADF, TYU. I should have selected more common words since this is pretty weird to grad out. But since this is almost over, I'm just gonna continue with it and finish this. So now we're gonna compare these 2 words with each other since we only have 2. If we had more, we will have compared them all again with the 0 matches. We only have 2, so we only compare 2. Let's erase this. So we compare CVA, ASD, and also we don't need this anymore. And before we compare it, I want to grad out the last step before everything gets repeated. Eliminate all words that don't have same number of matches to the guess as a return value. Okay, cool. So now that I actually wrote out the last step, we can loop through the first step again. And we have these words. Now we were gonna compare them to see the 0 matches. And we can do it pretty straightforward. I don't actually have to write out over here. Does it match? Nope. Does it match? Nope, 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 nope. So number of 0 matches that each of them have, it's gonna be 1 and 1. TVA, yes. So the one that is gonna get selected is gonna be this one. And after that, it's gonna call master that guess again. And after that, he's gonna send CVA ASD. And he's gonna compare it to this one. And he's gonna see that this is the correct match. So on every loop, we're gonna be eliminated a lot of words. So now I'm gonna start coding it out on the whiteboard. And I'm gonna be explaining each part of the code as the steps that I wrote before. So feel free to go back and watch the steps again and just to follow it through. So the first step was comparing the zero matches on each word. So we need to have a method to be more modular with the code that is gonna be matching each character on the word with each word on the list. So what I'm gonna do over here is I'm gonna have a method called public int match, and it's gonna be comparing two words. So it's gonna be comparing the string candidate, and it's gonna be comparing the string compare, let's call it. And now let's spread out the code for this. It's gonna be a pretty standard method. Just gonna count the number of the repeated elements. So it's gonna start at 0, and then we're gonna be doing a while loop for int I equals 0, I is less than candidate.length, and then I plus plus. So over here, if these two words matches, if cand dot car at I that equals, it's a character, so equals compare that character at I. So if they're equal, we're gonna increment the m plus plus, and then we're gonna return the m. So this is gonna be comparing the two words. That's part of the first step. I'm gonna be writing out here the number 1, so you see that this code is part of step number 1. Now to continue with step number 1, as we mentioned, we need to compare each word from the list with the other words and write out the zero matches. The way we're gonna do this is by having a hash map, and we're gonna have the word, and then we're gonna have the number of zero matches that it has on the side, and we're gonna be using the public int match function that we wrote before. So the first thing that I want to do is change this array of integers, of strings, I don't know what I'm reading, and change it to a list. And the reason because of this is gonna be a lot easier to be adding and removing words from the list than it is from the array. So let's say list string, and we say word. We are gonna call it list, and this is gonna be equal to new. We're gonna be saying new arrays status list word list. So essentially, it just converts this word list to a list, and it's gonna take all of n time because it has to go to each word in the array and then put it on the list. So after that, we're gonna be doing while list is not empty. We're gonna be continuing doing this. And what this is doing is doing the last arrow that I put on the steps, which it was once you get to the 4, to step number 4, you're gonna return to step number 1 and do it all over again. So it shrinks the number of possibilities, or words, better said, that we have on the list. So that's what that's doing, and I'm gonna write over here the loop arrow, and after that we can start the hash map, which is gonna be map string, and we're gonna have an integer, and let's call it zero match as before. Zero match, do not get confused. New hash map, and that's about it. So after that, we need to compare each word. So we're gonna have a string that we're gonna call candidate, and we're gonna go through all the words in the list, and we're gonna go through all the words in the list again, because we need to be sending out to match, to compare it, to update the hash map. So the way that we're gonna say over here is if match candidate and compare equals 0. So if they equal 0, it means that the candidate has a 0 match. So we're gonna update the hash map and increment it by 1. So we're gonna say 0 match, which is the hash map, that put to candidate, which is a word, and we're gonna say 0 match that get or default, to save a little bit of space over here. Then we're gonna say candidate. If the candidate has value, it's gonna return it. If not, it's gonna return a 0. And then we do a +1, and this matches this one, and this matches this one. And we put a semicolon at the end, and that should be it for step number 1. So let's put it like this. So now for the second step, we're gonna be selecting the first word on the list, and we're gonna be putting an integer that is gonna be storing the maximum value possible. And if there is a word with the smallest 0 match value on the hash map, it's gonna update the guess string and the minimum integer. So we need to do a for each loop on each entry on the hash map. So we're gonna say string guess, it's gotta be the first word. So equals to list.get 0. And then we're gonna say int minimum equals to integer that max value. Now we're gonna do the for each. So for map.entry, which is gonna give us each entry in the hash map, which is called 0 match. For each entry integer, then we're gonna call it entry, and then this one can be 0 match, which is what we call it before. So for each entry, if the entry that get value, if entry that get value is less than minimum, we're gonna update both of them. So guess will be equal to entry that get key, which is the word, and then min will be equal to entry that get value. And that should be it for step number 2, if I remember what we said correctly. Since we're running out of the space on the whiteboard, I'm gonna be erasing the match function that we wrote before. You can check it out again on the GitHub down below. And now I'm gonna be writing out the third part, which is getting the value returned by the master.guess function and sending out the guess that we selected over on the second part. So over here, we're gonna say int m equals to master.guess, and we're gonna be sending out the guess word. Was it master.guess? I don't remember, to be honest. I will say it is. If not, just check out the GitHub. If m equals 6, which is, so it equals 6, because if it equals 6, it means that all of the characters matches, so this is the secret word. So we just say return, since we don't return any value on this function. And that should be it for step number 3. So as I was recording the last part, the fourth part, my camera just for some reason shut down. It actually had battery and everything, but it shut down. That's why I like segmenting all of these, making the video more modular, just as the code. So last part, let's do it again. So step number 4 is this step that where we eliminated all the options that did not match exactly the same numbers as the one returned in the master.guess function. So the way that we're going to do this is by having a temporary list and adding the words that match exactly the number. And after that, we're going to point our old list to the temporary list, and then continue a cycle all over again, eliminating a bunch of options. So last part. So list of integers, of strings. I keep saying integers for some reason. So string temporary near array list. Okay, so once we have the temporary list, we can do a for loop. For each word that is on the current list, we want to see if it matches, if m equals, if it matches the same number returned by master.get. So if m equals match between w and the guess word, then we can add it to our temporary list. Temporary list at w. And after this, we can finally say list equals temporary. And that should be it. That was the last part. This is the code. Check it out on GitHub if it wasn't clear enough, if you couldn't see it over this whiteboard. I hope you like it, and see you on the next video.